We live in a time when digital technology is changing every industry. Museums are also poised to redefine the visitor experience. So with the combination of artificial intelligence, augmented reality, and other technological advances, we envision a more interactive, personalized, and memorable museum experience. So we promote you the MuseTech. MuseTech represents a revolutionary shift in museum interaction, harnessing the support of large language models and the cutting-edge technology to reimagine the conventional museum experience. This gives us a diverse audience, from the museum visitors seeking enriched experiences to museum staff aiming for efficient curation, to tech teams enhancing the platform's robustness. So the key functionalities encompass personalized tours driven by voice and image recognition, interaction dialogues with exhibits, and augmented reality integrations. So MuseTech's adaptive interface is designed with language flexibility and offers a two-way feedback channel between users and curators. Additionally, this platform delivers data-driven insights, leveraging AI to discern visitor behavior and preferences. So in essence, MuseTech bridges history and modern tech, offering an immersive museum experience while empowering curators with actionable insights. So let's dive into the details. How will MuseTech change the museum experience? We will go through the diagrams we developed for our project's first stage. Next, we will go through the ad hoc diagram. So this diagram appears to represent the architecture and interaction flow of our intelligent museum service, incorporating both a central MuseTech system and a real world, which we refer to as the external museum components. So we're starting with the system controller, the main hub that manages the overall flow and functionality of our system. It is directly connected to the user database, ensuring user data security through the secure measurement and security enhancement methods. There's also a deployment path to the cloud management. So as you can see, we got three user roles. We got the development team, the visitors, and we got the curator and staff. Curator and staff, which refers to as the staff, museum staff, as we mentioned before. So next is the MuseTech system. This is the technological heart of our project. It hosts the system front-end page, handles the application maintenance, processes the API calls, and offers automated activation recommendations. Within this block, visitor trainings and feedback will be analyzed. So next, we will go to the external museum. This is the block that represents the real-world museum components. We got the exhibit dialogue. We got the AR, VR section functionalities. This function points to the immersive technologies for enhanced visitor experiences. And there are also components for the museum events. So we got the museum events, we got museum exhibition, and we got the museum collections. Finally, we'll go to the databases section. We got the user databases. This is the a secured repository for user data. And then we got the MuseTech database. This is to stores the multimedia contents, include the image file, audio files for further analysis. So in summary, the diagram focuses on enhancing the user experience, analyzing visitor feedback, and ensuring data security. Is summary of our class diagram. So we're starting with the museum class. Museum class is the parent class that stores the museum's cross-functional attributes and methods. With it has three child classes. We got exhibition, event, and collection. And then SDR, these are the activities and items that a museum should have. And then we go to the controller class. It is used to control the operational status of the system with the methods to initialize, start, stop, and retrieve the status of the system. We define the controller class as the supreme parent class of our system. And then we move on to the user class. It is used to represent the system user with basic attributes such as name, email, and password, and including three identities. As we defined previously, we got visitor. It is used to represent a visitor with attributes to keep track of their visits, purchase tickets, etc. And then we got the curator and staff, and we got a development team class. So there's a special condition we considered for this to combine with the large language model we used. So visitors may provide different types of input when interacting with the system, right? So to handle and manage these different types of input, a subclass we defined as model input is derived from the visitor class. The model input class further derives three subclasses. We got text input, we got image input, and the audio input. These three subclasses represent input for text, image, and audios, respectively, and each subclass has its own special methods and properties to handle the corresponding input data. This design structure ensures that each type of input is handled appropriately, while also clarifying the responsibilities of each class. So for the interfaces, there are interfaces indicating virtual exhibits and augmented reality exhibits, suggesting the system supports the online and virtual tours or the augmented reality experiences. So overall, the class diagram provides a comprehensive overview of a museum management system and also accommodates both physically visits and virtually reality experiences. The interaction diagram, this presentation, we will focus on the visitor side and give an overview of the system operations. So we're starting with the first step of our system, login and register process. So the user sends a login register request to the system, and the system controller saves the information and requests permissions from the database. Once the permission is granted, the system provides access to the user. And then the visitor can do their interactions with the system. The visitor can book events. In response, the system controller checks event details and collects this information from the database. The visitor also has the option to search collections for this. The system requests collection data and fetches the details from the database. The visitor also has an option to suggestions related to the events and collections are provided to the visitor by the system. And for the visitor input part, the visitor can input queries in the form of text, voice, or image. For the text and voice inputs, they are transmitted to the large language model and then returns an answer from the model. For the image input, firstly, the image is uploaded to the local storage and then transmitted to the model for image recognition. So for the model interactions, the large language model, it provides data collection and also updates its status, and it also offers a model suggestion analysis and model enhancement capabilities. The model returns answers based on the visitor's input, which we refer to as the text, voice, and image. And then we can move on to the AI system for the user feedback analysis. When the feedback is provided by the visitor, this data is input into the AI system for user feedback analysis. The system returns user feedback data and also offers data analysis capabilities. So the last part is the security enhancement system. This system is responsible for ensuring the security and integrity of the data. So the overall, the interaction diagram illustrates how various functionalities and components in the MuseTech system collaborate and how data flows between these components. Next, we will talk about the changes and updates we will do in the stage 2. And first of all, we will remove the optional feature. And we will focus more on the key functions related to the large language model, which mainly is the text interactions, text responses and text inputs. And the image recognition and voice recognition part, we got some implementation difficulty, but we guarantee that we will try our best to solve the problem. And finally, the project will be deployed locally instead of deployed on the cloud. And that is the end of our presentation. Thank you.